Good morning, grade 8. Today we are going to start lesson 3, electromagnetic force. We mentioned before in lesson 1 and 2 the magnetism and the magnetic field. We mentioned magnetic field is the area of magnetic force around a magnet. Yes, this is called magnetic field. And the magnetic field spread as lines. These lines spread out from one pole to another pole as a curved lines and return to other pole and so on. Yes? In this lesson, electromagnetic force, we will speak about the relation between electric current and the magnetic field. Yes? In this lesson, electric current produces magnetic field. Yes? Electric current produces magnetic field. When we mentioned before in chapter 6, the electric current is a current that flows, or electric charges that flows in a conductor wire. This is electric current. When the charges flow in electric wire, what happens? Magnetic field produces. Yes, magnetic field produces. So, what's meant by electromagnetism? Electromagnetism, interaction between electricity and magnetism. The first part of electromagnetism, electro. Electro means electricity. And the magnetism, magnets. So, electromagnetism, interaction between electricity and the magnetism. Electromagnetism, I can see it directly, but I can see the effect of electromagnetism. Yes. Look at the circuit. Look at source of electricity. This is battery, source of electricity, and we have conductor wire connect the poles, positive and negative of it, and the wire passes through many compasses. All of you know the magnetic needle of the compass always point to the north direction. Yes? This experiment tells us how magnetism is produced by electric current, or how electromagnetism is produced when the electric current passes through a wire. Yes? Scientist called Orested noticed that when current pass through a wire and put a compass beside the current, the needle of the compass changes the north direction, deflects and changes direction. Yes? When Orested put many compasses like this in a circle, they found when connecting the current like this is without connection, all the needles point to north, no deflection. But when the current pass and switch on the circuit, the needle change its direction from north, number 1, and then 2 and 3, all make a circle by the changing the direction. Look at the needles, make a circle. This one, and after that this one, then this one, and so on. Make a circle by new directions. Okay? So, in this case, without current, the compass needles align with Earth's magnetic field, so it points to north direction. But when current flows through a conductor wire, the wire creates a magnetic field which makes the needles align with to form a circle around the wire. So changing in direction happens. Okay? First question, what is magnetic field produced by current like? Like what? The properties of the magnetic field that are produced by current, or characteristics of magnetic field that produced by current. The magnetic field produced by current, number one, has strength, and has direction. Yes? So, two main characters should we know about the magnetic field that produced by current. The magnetic field has strength. Number two, the magnetic field has direction. Number one, the field can turn it on if the current turn it on, or the current flows through a wire, so we have magnetic field. If no current, so no magnetic field produced. Yes? So the field can be turned on or off if current turn it on or off. Okay? Okay. Number two, the field may have its direction reversed if we reverse the direction of current. So if you reverse the direction of current, I reverse the field, or the field reverses automatically. Okay? The field may have its direction reversed if we reverse the direction of current. Two ways to change the strength of magnetic field. Well, how can you strength the magnetic field? We mentioned the magnetic field has a strength. How can you strengthen? Number one, increase the amount of current in a wire. We can use battery with 9 volt, we can use battery with 20 volt, we can use battery with more than 20 volts, so we have more current. So increase the amount of current in a wire, this strengthens the magnetic field. Number two, make a loop or coil with the wire. The wire, all of you know, the wire made of material that allow current pass flow. Yes? Now, what happens if you make a loop or coil, loop like this, circle like this? This is straight line, the straight line create magnetic field like this. Yes? This one direction. If you reverse this direction, the magnetic field also reverses. Yes? So number one, reversing the direction. You can do this exercise in your book, page 209. Yes? Number A, we can reverse the direction if you want to reverse the magnetic field. يبقى number A, reversing the direction. Number B, make a loop. Yes? Make a loop. This is strengthen the field also. So changing the strength. This is number B. Okay, number three, we can change also we can strengthen the magnetic field, varying the strength of current. So increase the amount of current. Or I can turn off the current. If you turn off, so no magnetic field. Look, straight line, without any magnetic field. So I can switch on current, so we have magnetic field. Switch off current, so no magnetic field. Okay, so last question in page 209 ask me about magnetic field produced by current can be changed by shape, direction and strength. Okay, in page 210 we have two types. Move to 210. Before we move in 210, I will repeat again the point of making a loop or coil in a wire. This is strengthening the magnetic field because this is making a lot of bunches, bunch close together in a loop, amount of bunches of magnetic field, 1, 2, 3, 4 in a loop beside the straight line. So this is strengthen the magnetic. Yes. Look at what characteristics of solenoids and electromagnets. What is solenoid? We mentioned, we can strengthen the magnetic field around the wire when a current flow through a coiling wire. Coil wire. Look at coiling, make loops like this. This is coil wire, not straight. This is make the magnetic field more strengthened than a straight one. Yes? So this is called solenoid. Make a coil and connect the two ends of the wire by the source of electricity. So we have solenoid. So solenoid is a coil of wire which is wound into many loops by running current through it. The two ends of solenoid act as poles of magnets. So in this case we have magnet and we have magnetic field. Look at the magnetic field when you coil the wire and connect the two ends by the electric currents. Yes, so we have magnet and magnetic field created. But what about electromagnets? Also electromagnet solenoid, but with a ferromagnetic core. Put inside the coil, put a ferromagnetic core. حط أي material made of iron. So we have electromagnet in this case, and I create magnetic field strengthened than other solenoid. Look at the magnetic field. Look at strength, more strength than solenoid. Okay, current in the wire, the magnetized core produce magnetic field of electromagnet. Okay, the magnetic field of an electromagnet, the magnetic field of an is much stronger than solenoid, as I told you. Why? Because we have material made of iron inside the coil, allow more current, produce more magnetic field. Yes? How can you strengthen the electromagnets? How can you increase the strength of electromagnet? In 4 ways. Number 1, increase the current, as I told you, in the solenoid. Number 2, add more loops. Add more loops of wire to the solenoid. Number 2, wend the coil of solenoid closer. When you make the coil like this, close the distance between the loops, close. Make it more closer. This is creates more magnetic field or strengthens the magnetic field. Last one, use material more magnetic than iron. Fee material more than iron. Yes, miss, we have Alenco alloys. What is Alenco alloys? Alenco, look at the word Alenco. Al means aluminium, Ni means nickel, Co means cobalt. So if you mix 3 different metals, aluminium, nickel and the cobalt alloys, this is called the alloy. If you make a mixture of solids together, firstly melt them together, then make the mixture of the metals, this is called the alloys. Alloys are ferromagnetic that are used to make permanent magnets and they has character more than iron itself. Yes, magnetic properties more than iron itself. Alenco. So use material that has more magnetic than iron for the core. Look at simple electromagnet. You can make it at home at activity. Look at battery, 1.5 volt only, and conductor wire, and nail, simple nail, and wind the wire around the nail. Make many loops and connect the 2 ends by the 2 ends of the battery or 2 balls of the battery, and try to approach this nail to the bed like this. What happens? It will attract it because I have electromagnet. The magnetism produced by the electromagnet. Yes, using electromagnets in electric motor, in earphones, in electric bell, and also used in junk yards to lift old cars, because I can lift heavy cars by the huge electromagnets that called the cranes. Look at the difference between solenoid and electromagnet in page 210. And also we can do the assessment together in page 211. Look at the electric bell mechanism. Yes, how electromagnets make doorbell ring. Look at what effect will the magnetic field have on the steel bar. ادي الستيل بار اللي هو connect للبutton. If you press on the button, so I will turn on the circuit. When you turn on the circuit, this is allow electric current pass. So look at 211, the clapper of the bell. It will touch the bell and the sound is produced. What happened? What turns off the electromagnet? هعمل ايه عشان اعمل turn off electromagnet؟ بعمل switch off. يبقى pull the ايه pull the steel bar, this steel bar away from the circuit. This is breaks the circuit and turn off electromagnet. We have question in assessment. What is solenoid? Solenoid is a coil of current carrying wire produces magnetic field. 4 ways to make electromagnet stronger. Look at the 4 ways to make electromagnet stronger. And the last one, I know both solenoid and electromagnets are what? Both solenoid and electromagnet use electric current to produce strong magnetic field. Okay, thank you all.